Remember that on your Google Classroom, the videos are posted from each day. So if you missed yesterday, you can just go back and review. But what we talked about was there's two different plots that we have. We've got segmented bar graph. So that's where we stack up all the bars to make 100%. It's kind of similar looking to a histogram, but it stacks up the full data to make that 100%. Okay, mosaic plot are segmented bar graphs where the widths of bars are proportional to the group size. Okay, and we saw that yesterday with the students, how we surveyed 500 students versus the 100 teachers. Okay, and then we talked about association. So if knowing the values of one variable helps us predict the other variables. And we talked about how the segmented bars are different. Okay, and that was kind of back with 1.1. We saw that a little bit more with the math and English core class predicting the elective class. Okay, so those were the two things that we talked about yesterday. Okay, do y'all need a couple more minutes on the check your understanding? Okay, all right, go ahead and do that now. All right, so what you should have done is you should have calculated for currently working, not working, but had a job, and then never had a job. Okay, remember, first thing that we do is we total up on the outsides. Okay, so we total up the rows and the columns, and then we give the total number of students. Okay, and so what you should have gotten is currently working should have been 0.275. Not working but had a job is going to be 0.431. And never had a job is going to be 0.294. Everybody good on that one?
Is it acceptable?
I would leave them as decimals. I would leave them as decimals for right now. Okay. On the next one, for seniors, currently working 0.375, not working but had a job 0.5, and never had a job 0.125. Are there any questions about part A or B? Okay, as you're doing this, you can also fill in this graph and you can put the corresponding parts in here. So that way you see the chunks, yeah? For part C, it says, write a few sentences summarizing what the display in part A reveals about the association between grade level and job experience for the students in the sample. What'd you say?
Higher grade level.
Okay. So does one thing help us predict the other? Okay, what is it? So knowing that grade level helps us predict the job experience. Okay, does everybody understand that? Knowing the grade level, so whether they're junior or senior, is going to help us predict their job experience, right? How many of y'all are seniors? And how many of y'all have a job? Okay, if I ask that to a class of juniors, how many are going to raise their hand? A little less, right? Partially because of like, the whole driving situation, right? Okay. So what?
So just get your license.
They're not old enough.
Get your license. Okay, so further work with mosaic plots. So consider a group of individuals for whom data was collected regarding two variables. So hair color, black, brown, red, or blonde, and eye color, brown, blue, hazel, and green. Below is a two-way, as in two categorical variables, contingency table of this data. Okay, using the table, we can analyze the question. Is there a relationship between hair color and having blue eyes? Okay, before we get started, what do you think?
Yes. Yes.
Yeah? Okay. To do this, we need to further break down the data to make the contingency table that isolates our variable. So using the table above, condense the data to complete the following contingency table. Okay, so we're going to fill in here. How many people from this table had black hair, blue eyes? 4. All right, so we're going to go ahead and fill that in. I'm going to scroll down so we can fill in this table. All right, so we got 4. All right, how many had brown hair but blue eyes? Okay. How many had red hair but blue eyes? 3. How many had blonde but blue? And then how many is that in total? Okay. All right. What about not blue and black hair? So anything.
14.
Okay. What about brown hair but not blue? Okay. What about red hair but not blue? What about blonde hair but not blue? And then total. Okay. Remember, we want to total all of the columns as well. So that's going to be 18, 62, 11, 22, 113. It feels like we're almost copying the exact table above, but what are we actually focusing on? Blue eyes. Okay, so we're kind of focusing our table a little bit more. The one above has a lot more data, right? We want to focus it on that blue or not blue. Okay. Does everybody understand why we did that? Okay. All right. So using the contingency table, make a mosaic plot for the data. Okay. So what you want to do first is you want to find those percentages first. Okay. So how much black hair out of the total? So if we did 18 out of 113, how much is that? It's okay to grab a calculator.
15.
Okay. So we're going to say roughly 16%, right? Okay. What about 62 out of 113?
15.
All right, so we're going to say 55%. Okay. What about 11 out of 113? All right, about 10%. And then 22 out of 113. 19%. Okay, so what we did was we found the percentages for each one of the hair colors. Everybody okay on that? All right, on your mosaic plot. Okay, on your mosaic plot. So first we're going to label the sides. That's the first thing we want to do. If you don't label your axes, automatically points taken off. Doesn't matter if your graph is correct or not. Does everybody understand? You have to label. Those are the little points that they like to take off drastically. Okay, so on the side, we're going to say relative frequency of eye color. And when you label this, you want to be as specific as possible. Okay. At the bottom, we're going to say relative frequency of hair color. Okay. I know this is a little squished, but it's okay if you just put it right here. Relative frequency of hair color. Okay. Remember, with mosaic plot, you're going to use 2 different colors, right? Okay, so I would maybe use a pencil and a highlighter, or you can shade one region and not shade another region if you don't have 2 different colors. Okay. All right. So other percentages that we want to look at are how much of a percent of the blue from each hair color we have as well. Okay, so down like kind of in here, we're going to look at how many black-haired, blue-eyed people did we have out of the total black hair people we had. Okay, 4 out of 18, and that's going to give us that 22%. The next one, we had brown hair, blue-eyed out of the total brown-haired people. 3 out of 11. Did you say 60?
3 out of 11. I skipped them.
27%. And then the last one, 15 out of 22. That's going to be 68%. Why are we calculating all the percentages? Because we're looking at relative frequency. When we do the mosaic plot, we're doing relative frequency. Everybody good? Okay, so on the bottom, remember we always want to start at 0, okay? And we want to space this out. Since we're going to cover 100%, we're going to cover 100%, right? I would probably do these in increments of 10. That's probably going to make it easy. Okay, so we're going to have 10 dashes on the y-axis and on the x-axis. So go ahead and space those out. Okay, that was roughly. Everybody okay on that? Okay, so we're putting the dashes. Okay, since it's in a box, that top line is going to be your 10th one. Good? Okay, so now let's just look at the total hair color. Okay, so our percentages for hair color. So what was our percentage of hair color for the black hair? What was our percentage for black hair? 16%. Okay, so coming over here, we're going to find 16%. So 10, 20. It's going to be right in here. Okay, and so we're going to just draw a straight line up, and we're going to label this black. Everybody see it? Do we see why I did that? So it was 16% of the data for the hair colors, and we drew a line at 16%. Does that make sense? Okay, for brown hair, how much do we have? What was our percent? 55, right? Okay, so we have to go and cover 55%. So we're at 16 right now. So what's 16 plus 55? Okay, so we're going to go over to 71. So 10, 20, 30, 40, 50, 60. These are not spaced out correctly. Give me 1 second. Sorry, it looks a little janky. I promise it's a lot more challenging to write on this thing. 1, 2, 3, 4, 5, 6, 7. Okay, so right in like here. And we're going to call this brown. Everybody good? Okay, what about red hair? How much? 10%. So we're going to go from 71% to now 81%, and that's going to be the red hair. Okay, 71% to 80%. This guy over. Let's cover red. And that last little chunk is going to be blonde. Is everybody okay on the hair color part? We're good? Okay, so now we're going to look at, are they blue or are they not blue? Okay, so looking back at the black one, how many of the black hair was blue? 22%. So coming into this little section, I would suggest taking a color. Okay, we're going to go up to 22%. So 10, 20, gonna be right in there. So that means that we have 22% that are blue. And how many percent is not blue? I probably should switch those colors. Let's go not blue up here. Okay. Okay, looking at the brown, how much did we have? Out of the total brown, how many blue eyes did we have? 29%. Okay. 29%. So we're going to go up to 29%. Draw all the way over. How much do we have for the red that were blue-eyed? 16%. Oh, 27%. 27%. Okay, and then what about blonde? 68%. Okay, I'm gonna put a pause because I know you're still catching up on drawing it. Okay, so here's number 3. Now that we've drawn this awesome graph, mine's a little janky. Now that we've drawn this awesome graph, we have to make a statement about it. Okay, so on number 3, it says, based on the mosaic plot, is there a relationship between hair color and eye color? So we're going to say there is an association with eye color I'm going to write this on the side because I know you cannot see that. Let me try this again. There is an association between eye color and hair with respect to blonde and non-blonde because look at it this way. With blonde, we cover a majority of that section, right? And most people that you see that are blonde hair, what do they have? They have blonde or blue eyes, okay? Or they have like green eyes, depending on their parents, right? Okay. And then the rest of us, we get whatever's left over, right? I like my hazel cookie color. It's fine. All right. So whenever you do a mosaic plot, there should be a sentence about it. You've got to tell what's going on here. Okay. You always want to refer back to what is the question asking? What was our question initially asking? Okay. And we see that, right? Okay. So when you do a mosaic plot at the bottom, you should have a sentence about it. Does that make sense? Okay. Cool. All right. Go and flip to the next page. All right, we're gonna put a little pause on this though. I need you to think about your shoe closet. Okay, some of y'all have a ton of shoes. Some of y'all don't have a ton of shoes. It's okay, no judgment. I need you to think, how many pairs of shoes do you have in your closet? Okay. So I want you to think about that. Also take out the practice from yesterday, the one that was 1.1 and 1.2. We're gonna do practice problems. Yes, it's pairs of shoes, not individual shoes, but pairs of shoes. Okay, go ahead and take out the practice problems from yesterday. If you were not here, they're up in the purple basket on the left. Okay, you're going to do problems 5, 6, and 7. 5, 6, and 7. Okay. All right, we're going to take about 5 minutes to do that. And then we'll jump back in with our notes. Okay. 5. What'd you get for part A? 57% or 0.57, right? Okay, what about B? 34%. Okay, and then what about C? Is there an association between age and preferred listening format? Yes, why? Okay, I want us to get comfortable with using the terms more likely, okay? Because we can't say like it's definite, right? We want to say they're more likely to do this, okay? All right, number 6. Based on the following graph, a counselor concluded that the number of students enrolled in AP Pre-Cal was more than double the number of students enrolled in AP Stat. Do you agree? What's wrong with this graph? Go ahead. It doesn't start at 0. So can we really say that? No. Okay, so this is misleading because it doesn't start at 0. You got to put that 0 there, right? So this could be exaggerated, right? Yeah. And we can't really tell what this one is, right? Okay. All right, number 7. This in the following graph, it appears that the Toyota has sales that are more than 4 times as big as the sales from Ford or Honda. Explain why this is misleading. Yep.
The graph is our one, also the bar, like it's not using bar, but using the bars.
Yep. So if you ever see pictures instead of the bar graph, wrong. It's already misleading. Okay. Because this looks huge by comparison, right? Yeah. Okay. Good. All right, let's go ahead and go back to our lesson. Back to our lesson. All right. Let's be honest. How many shoes you got? How many shoes you got? Okay. The first thing is the number of pairs of shoes, a categorical or quantitative variable. How? Why? Because it's a number, right? I ask you a question, you give me a number back. That's quantitative, right? Okay, good. So quantitative. There we go. Quantitative. Okay. Can this variable have decimal values? No, if you got half a shoe, homie, you need to go shopping, right? Okay. So, no, this is called a discrete variable. That's where there's no decimals. Right? Okay, continuous variable has decimals. Okay, continuous variable has decimal. Discrete variable, no decimals. Okay. We good? All right. So we're going to take like 2 minutes. Hopefully we can do this quick. What I want you to do, I want you to think about the number of pairs of shoes you got. Okay. And we're going to put them up on the board. You're just going to come up and mark it and just put a dot. Now, I know, so when you draw this, you want to make sure that you have frequency on the side. Notice how it doesn't say relative frequency. Okay, so frequency is the number of times it occurs. Relative frequency is a percentage. Does everybody understand the difference? Okay, so with your histogram, on the bottom, you're going to go from 0 to 5 and then include that number, how many there are, how many instances there are. And then from 6 to 10, how many there are. And then 11 to 15, how many there are. And then 16 to 20, how many there are. And there's going to be a gap in between here. There's going to be a big gap. And then, yeah, because, you know, I'm special. It's an outlier. Okay, and then put the 35 to 40. Good? Okay, so take a second. Copy that down. So things I want to point out. There's no space in between the bars. Notice how there's a gap in between here. Okay, this is called a histogram. Okay. And now we're going to do my least favorite plot. I personally think these are useless, but they somehow just keep popping up. Stem and leaf plot. Do you remember those? Stem and leaf. Yeah. No, it's not box and whisker. Okay. You'll remember it once I show you. So stem and leaf plot. Okay, it's just kind of like a different way to do like a dot plot. Not really, but kind of. So for each number, what you're going to do is each number is going to be two digits. Okay, so the number 1, it's 0, 1, right? Okay, so the second number is going to go right beside this column right here. So for 2, the first digit is 0, then you have 2. You're going to write 2 right here. We're going to do it again. And then we're going to do it for 4. And then we're going to do it for 4. And then we're going to do it for 5. We're going to do it for 5, 5, 5, 5, 5, 5, 5. And then we're going to write out 6, 6, 6, 6, 6, 8, 8, 8. And then for 10, we're going to put 3 zeros here. 11, 12, 14, 15, 16, 18. And then for 35, we're going to put that right there.
Wow.
Like I said, I don't think that this is a helpful way to show any kind of data, especially with the numbers of pairs of shoes. Because like majority of us are going to have between like 1 to like 20, right? That's where most of our data is.
Well, one slight difference is it does show you the specific values, whereas the histogram is it's grouping it into ranges. This one, you can see every individual data.
Exactly. So we know that there was 1 pair of shoes, 2 pair of shoes. Okay. Write a little bit smaller than I did. I put all the numbers on the board. So like if you get caught up, they're there. Okay. Are we okay on it? 1, 2, 2, 4, 4, 5, 5, 5.
2, 3, 2, 4.
It's okay. Use that data. Use that data. Okay. Take a moment, draw that stem and leaf. Okay, you always want to make sure for stem and leaf, you're saying what you're actually looking at. So we were looking at the number of pairs of shoes. So that label is down here at the bottom. Okay. Feel good? Does that make sense? Okay. All right. So on number 4, how many pairs of shoes does the typical student in our class own?
5.
Okay. We can say probably between 1 and 10-ish, right? Somewhere between 1 and 10. All right. So now here's the mathy part. Here's the information that you want from today. Okay. This is kind of a little bit of a review, but describe the distribution of the numbers of pairs of shoes for your class. So look at the shape. Okay. Even from the stem and leaf plot, we can see there's a lot up at the top and there's not that much at the bottom, right? So remember back in algebra, so this would have probably been 8th grade. If it looked like this, did we call it skew right or skewed left?
Left.
Skewed right. Skewed right. Okay, and here is the way that you remember it. The tail tells the tail. Okay, so the tail of the data tells you whether it's right or left. So this has a tail over here. Is this the right or the left side?
Yeah.
Oh God. Right side. Right side. Okay, so it's skewed right. Okay, other shapes that you should probably know if you don't remember these is skewed left. Okay, unimodal, bimodal. Okay.
Yeah.
But for ours, we've got skewed right. Okay. Now, are there any possible outliers?
Yes.
Okay. First of all, y'all hating. Okay. So 35 is a possible outlier. Probable outlier. Thanks, guys. All right. Now we're trying to find the center. Remember, center is just a different way of saying the average or the mean and the median. Do you remember how to find those two things? Do you remember? Okay, so we add all up the numbers and then divide by how many numbers there are. For median, we find the middle number. Remember, you have to list them from least to greatest and then find the middle. Do you remember? Okay, take a moment, try to find the mean. So that's the average. And then find the median, which is the middle. Take a moment, try that. All right, tell me what you got. 8.8. And then 6. What'd y'all get? Did y'all get 8.8? You got 9.5. Anybody get anything else? All right, how many y'all got 8.8? And I got 9.5. How many y'all didn't do it at all? Good grief. Okay, so let's try it again. All right, look at the numbers that are on the board. Okay, and I will say I'll give us a little bit of grace because like the dots were a little questionable on the board. So yeah. All right, so I got about 8.8 or 8.9, and then your middle number was what? 6? Everybody got that? Okay, good. All right, so 2 things I don't want to mention on that. If the shape is symmetric, what does the word symmetric mean? Equal on both sides. You're going to use the mean. If it is skewed, then we're going to use the median. This is super important. This is super important. They always ask a multiple choice question of whether you should use the median or whether you should use the mean. Okay, so symmetric, you're going to use the mean. That's the average. If it's skewed right or skewed left, we're going to use the median. Okay, why does it matter? Go ahead.
Because it's skewed, the average is going to be skewed or the numbers are.
Good. Okay. Everybody good on that? Okay. The mean is going to be in that middle anyways. Mean's going to be a little bit more accurate just based off of numbers. It's going to have like a little bit of a difference, but true middle. Remember your bell curve? Right down in the middle. Right? Good? Okay. All right. Variability. So we're talking about spread. So what is our range? How do we find range? 0. Did we have a 0? 1 to 35. Okay, so our range, we're going to find it by taking 35 minus 1. So our range is 34, right? Other ways to measure variability, things you should probably know, are standard deviation. What is standard deviation? Okay. What is IQR? Okay, and what is that?
That's like the
starts with midpoint is in.
It's 25% of the data. Okay. It's actually 50% of the data. The IQR, we go from Q3 minus Q1, right? It's that middle piece. Yeah, 25% of the data is on the outside of the IQR on both sides. Does that make sense? Okay, we remember from Box and Whisker, it looked like this, and this was the IQR. And this was 25%, this is 25%, and this was 50%. Yes, we remember that from Algebra 1. Okay, good. Okay, so which of these 3 types of display do you prefer and why? Neither. No, you gotta pick one.
IQ1
Okay, no, data, displays,
data.
displays, the graphs up at the top.
Histogram.
The histogram, why?
Histogram or ICE.
Okay, go ahead. Okay. I also think that the histogram is a little bit easier to plot.
Which one's the
The bars on the right. So either the bars on the right or the stem and leaf plot. Okay. So histogram, it's easier to plot as well as you don't have to plot every point. So like, for instance, we kind of grouped together 1 through 9, right? And then we grouped together 10 through 15, right? Okay. So you don't have to plot each point. Why would you want to pick the stem and leaf? Because you're weird. Oh, okay. What did he say earlier about the stem and leaf?
It shows you every individual value.
Okay. So shows every value. And this is also kind of helpful with a small set of data. I'm writing on the bottom of the wall. This is helpful with the small set of data. So when you go into your eClass page, you should see a textbook. The textbook's going to look like this guy, the practice of statistics. Okay, I need you to click on it. Okay, so once you get in, go ahead and click on here. Okay, if you haven't already done so, make sure that you joined that Google Classroom. If you need the code again, there it is. Okay, what I did yesterday was I created a document with the YouTube links. Okay, like I said, I record every lesson. So if you miss it, you can go back and watch it. Or if you're right before a test and you want to go back and review, that's fine too. Okay, so those are there for your use. Okay, so go ahead and make sure you join the Google Classroom. And then I need you to access the textbook, which is the practice of statistics.